So today I'm going to talk about hydrogen projects and putting them into operations. This is going to be a somewhat general view. So I would like to start with the question: when does a project actually start? And with almost 100 hydrogen refueling stations that we already have online in Germany, um, you know, is it easy? Does it really start with just selecting a location and going for it and just delivering a station? Is it almost as easy as picking up something from a shelf in a supermarket? Well, I think there's a number of things that still need to be considered. It's not quite as easy as just picking and picking something up and putting it down at the other location. I think there's a number of questions around your hydrogen supply and the questions around how it gets delivered, how the interfaces work, whether you can actually get it at a commercially relevant rate. And there's a major question around security of supply. If you, for instance, choose to go for liquid hydrogen supply, right? We may have heard of Hydrogeddon or the hydrogen apocalypse taking place in California or also in Munich when Munich ran dry. There's a number of things to consider, right? And in our opinion, it's unfortunately not quite as easy as going to one of the IGCs and picking up the station that you would like, because one of the troubles that you will also face very quickly is that you will be, as a thank you, presented with a supply contract that locks you in for a number of years, which makes it practically impossible for you to make any money on the infrastructure. In addition to that, what about these? We know that hydrogen moves, in addition to the passenger vehicle sector, to a number of heavier applications. And I would dare to say that there is basically no equipment out there which can currently really serve the needs of these applications, right? Whether we're talking about buses, and we know that for it to be commercially feasible, we would need to come down with costs by quite a lot. And we would actually, and this is probably the biggest challenge, we would need to start fitting into the cycle times of bus depots. And that is something we have not seen demonstrated yet. For a little reference, maybe, typically a bus depot, when they service their vehicles, they use the time that the vehicles refuel to also clean and prepare the vehicles for the next round trip. And they very often have only between 4 to 6 minutes to actually service the vehicle to a point where it can go on the road. If they do not manage to do that, it needs to go to a different queue, very often for larger maintenance. For heavy duty, the situation is not even better, because here we are still talking about how we actually want to store the hydrogen on board of the vehicle. The pressure level is undefined. We heard in a previous presentation that there might be a path for cryocompressed or even for liquid. Again, with all the questions of security of supply, and I think the owner and the operator really does need to ask themselves the question whether they want to be locked in a supply position where only two companies essentially can supply liquid hydrogen across Europe at the moment. So there's lots of questions that need to be answered. And yeah, where do we go from there? I think if we take it back to first principles, what we need is essentially two things for any of these applications. It's efficiency and reliability. And when you think about it, the efficiency is highly dependent on the entire supply chain. It's not only the hydrogen refueling station itself that you place somewhere in a chosen geography and where you think you may have good customer turnaround. It really is the entire chain that leads up to the hydrogen refueling station. And there's a number of things that can be and have to be solved along the supply chain to really optimize the cost of the hydrogen that then gets supplied to the customer. So, for instance, the pressure profiles across the supply chain there is something that can be highly optimized. You can, by choosing and playing around with that, you can choose where you place your compressors in the supply chain. You can put them, for instance, in a centralized location, and basically move around duty between electrical power duty between places along your supply chain. This is highly interlinked with what you see on the right side, with the reliability and the concept of operations and the design of your plant, right? So you cannot really just pick something from the shelf and just place it somewhere. You really have to think the whole supply chain through. And that will do several things for you. It will greatly increase the reliability if done right, and it will decrease the cost of the hydrogen supplied. So if you get both things right, it will result on one hand in acceptable costs to user, and on the other hand on good results with reliability. Coming back to reliability for a couple of seconds, and this is where the operations part of this presentation kicks in. Reliability is really designed into the supply chain. It's not enough to throw ever increasing amounts of maintenance at stations, right? In my previous life, and you mentioned it, I worked for a rather large energy company, and I had the pleasure to work on a very large industrial site in the Middle East. It measures about 2 by 2 kilometers in size and is full of process equipment. And I had a maintenance manager there who quoted, "You really know you have a problem when you're getting good at fixing things." And that means if there's a systematic error, you cannot fix it by increasing the resources that you spend on fixing it. You have to address the systematic error. And this is where we still need to improve in the hydrogen world. And we actually do see it in the field. When we look at the passenger car stations that we have in operation, we know there's a number of bad actors, and we really need to start addressing those also by looking across the supply chain how these problems can be tackled. For instance, if we have compressor problems, maybe it's a good idea to move the main duty of compression somewhere else, further up the stream, for instance. Right, and this is really the point that I'm trying to make today, is that by optimizing your system, you can do that and have to do that on many ways, on many etappen, right, and many steps along the supply chain. So it starts very large with your concept of operations and really understanding what the purpose of your project actually is, because from there you can make these choices. You can really choose where you put elements of your supply chain. Then you design your plant. So you actually choose the bit that goes to be customer facing, and that can be designed in a number and optimized for a number of different criteria. So you can optimize that for low capex or high reliability, or the lowest cost of hydrogen that is supplied to that customer. You can design it to be scalable, right? So all of these supply chains, depending on what you choose to do there, they look very different. You may have a compressor which is very large, and at the very beginning of the supply chain, you may have a range of compressors which are at your customer location, for instance. So it really depends. You really need to understand what you're trying to achieve in order to get there. And then in the very last bit, the greatest level of detail, you actually need to design all these elements that go into the supply chain by looking at the components, at the systems, as the subsystems that you put together, and making sure that the interfaces work well. To give you an illustration of what we think is happening, let's put ourselves in the shoes of a bus app operator. So As a bus operator, we are under a lot of pressure today to decrease our CO2 output. There's the Green Vehicle Directive. We know we have to change. We know we have to put zero-emission vehicles into the on the road, but at the same time, because we're very often private-public partnership or something similar, or we are serving the public space, we are under a lot of cost pressure. There's nobody throwing tons and tons of money at us. So, and at the same time, we actually are obliged to provide a service to the public, which means that naturally we are very risk averse. On the other hand, what that does to the infrastructure, and that is, yeah, a negative feedback loop really, is that the infrastructure has no assured demand because the amount of fuel, the amount of hydrogen which is dispensed is very low. We know that that infrastructure is going to get outdated very, very quickly because we know it's not going to remain with that pilot project, which the bus operator basically has to choose to work today. And it means that the operations of that equipment become very expensive per kilogram of hydrogen. So unfortunately, there's this negative feedback loop, and you almost find yourself in a position where you need to take the leap of faith, right, to deploy large infrastructure and hope for the best that your vehicles are going to last, which is not a great position to be in. So the solution that we see there is to create a system of systems. And what we mean by that is almost like a toolbox, like a Lego set of elements that you can configure and arrange in a way that you can tailor the specific supply chain that you're going to deploy to a customer very specifically with a very exact target in mind. So to give you again the example of the bus operator, what this system of systems would potentially allow you to do is to move the compression upstream, have high capacity, high pressure tube trailers that you use, and then, for instance, think about, could we eliminate the compression on site in a bus depot, right? This is just one example of a particular supply chain that you can take out of this system of systems, which may be fit for a bus operator because it decreases the technical complexity on site, it increases the reliability, and also gives a buffer storage to the bus owner or the fleet operator to not be reliant or not to have to rely on daily deliveries, for instance. If done right, we think that this approach will result in acceptable costs to the user. It will also allow the reliability and availability of the stations to go up. And because the system of systems actually consists of elements which are individually proven, improved, and validated on a number of occasions, it will automatically lead to a better safety and performance, performance. And that is basically what we do. We create integrated supply chains. We look at creating that system of systems, and by developing the products and the digital platform that make up the system of systems, we're able to reconfigure these elements in a way that will meet and exceed, hopefully, the expectations of a regional operator, and therefore, basically solve the operational issues that we have today. I would like to end and are open for questions.